This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through prime factorization. So what does that actually mean? Well, what we're going to do is we're going to take an integer, which is a whole number, and write it as a whole bunch of prime numbers multiplied together. And later in this video, we're going to use this to find highest common factor and lowest common multiple. So let's start with a number like 45. What I want to do is I want to write 45 as a whole heap of prime numbers multiplied together. So I'm going to create a factor tree. So I start with any factors of 45 other than itself and 1. So I'm going to choose 9 and 5. 9 times 5 is equal to 45. What I do is I keep factoring these numbers until I'm only left with prime numbers. So we have 9 times 5. Now, 5 is a prime number, so I can just circle it. I'll stop there with 5. But 9 is not a prime number. So what I do is I'm going to now factorize 9. So it would have to be 3 times 3. So, of course, 3 is a prime number. So now I'm done. So what I've figured out is that 45 is equal to 3 times 3 times 5. So you can see here I've written 45 as some prime numbers multiplied together. So that's the answer in expanded form. If I was asked to give it in index form, of course 3 times 3 we write as 3 squared. So 3 squared times 5 is the prime factorization of 45. It is 45 written as a whole heap of prime numbers multiplied together. So it turns out there's only one way to do this. Each prime factorization is unique. I mean, we could write 45 as 5 times 3 squared, but that has the same numbers in it. So there's only one possible answer. It actually doesn't matter which factors we originally started with. I chose to start with 9 and 5, but I could just as easily have started with 15 and 3, because of course 15 times 3 is 45. So 3 is a prime, I can stop there, but 15 is not prime. It's divisible by 5 and 3, so I'm going to write 15 as 5 times 3. So then after I've written that, I can stop because I've got prime number, and prime number. I've only got prime numbers down the bottom, and I would have the same answer. 45 is equal to 5 times 3 times 3. Or in index form, 3 squared times 5. Remember, the order in which we multiply numbers doesn't matter. So 5 times 3 times 3 is exactly the same as 3 times 3 times 5. There's no other way to write the prime factorization of 45. Okay, now what we're going to do is we're going to look at using these factor trees to find highest common factor and lowest common multiple. So we're now going to use factor trees to find the highest common factor of 40 and 48 and also the lowest common multiple of 40 and 48. So to do that, we're going to follow these steps. So firstly, we're going to draw factor trees for each number. So I want to find the highest common factor of 40 and 48. I'm going to draw a factor tree for 40 and a factor tree for 48. So remember, I can start with any factors of 40, so I'll just choose 8 and 5. So 5 is a prime number, I can stop there. 8 on the other hand is not, so I need to factorize it further as 4 times 2. 2 is a prime number, unfortunately 4 is not, so I need to factorize again. So I've got 2 and 2. So now I've written 40 as the product of prime numbers. So 40 is actually 2 to the power of 3, because there are 3 2's there, times 5, and then we're done with that one. Alright, let's now do 48, a factor tree for 48. So I can pick any factors of 48 that I want, so I'll just start with 12 and 4. So, is 12 a prime number? No, it's not. So I'm going to factorize it further as, say, 6 and 2. 4 is not a prime number, so I'm going to factorize it as 2 and 2. So, of course, these are prime numbers, but 6 is not. So I need to keep going until I just have prime numbers at the bottom. So 6, I can factorize it as 2 times 3. And of course, once again, 2 and 3 are prime numbers. So I've written 48 as the product of prime numbers. 2 times 3 times 2 times 2 times 2. There are 4 2's multiplied together. So I can write that as 2 to the power of 4. And there's also a 3. Okay, so I've done the first step. I've written both numbers as the product of prime numbers by using a factor tree. Now what I have to do is put the factors in a Venn diagram. So this is what a Venn diagram looks like. It's always a rectangle with 2 circles inside. They're the circles I'm talking about here. So there's one circle for each number. One circle for the number 40 and one for the number 48. What we're going to do is put inside these circles all of the factors of the numbers. So in this little bit in the middle, that's where there's an overlap between 40 and 48. We're going to put the factors that are common, the factors that both of these numbers have. So you can see both of them have 3 2's. So I'm just going to cross out these 3 2's so I know that I've already done this. So 3 2's are common to both of these. So I put in the middle 3 2's. So what goes over here are the factors of 40 that aren't in the 48 prime factorization. So you can see this number 5. It's in the 40's prime factorization, but it's not part of the 48 factor tree. So I put that number over here. So you can see that the numbers inside this first circle all multiply to 40. So I do the same over here for 48. So I've already got the 3 2's here, but I need to add in another 2 and a 3. They are in the 48 factor tree, but not the 40 factor tree. So notice all of the numbers inside this circle here multiply to 48. So how do we use this to find highest common factor and lowest common multiple? So these numbers in the middle, you multiply them together to get the highest common factor. So the highest common factor here of 40 and 48 is just going to be 2 times 2 times 2. All of the numbers inside the center multiplied together. So 2 times 2 times 2 is obviously 8. Highest common factor of 40 and 48 is 8. So to find the lowest common multiple, we multiply all of the numbers together inside the circle. So we go 5 times 2 times 2 times 2 times 2 times 3. So we go 5 times 8, which is 40, times 2, which is 80, times 3, which is 240. So some people find it a bit difficult to use factor trees to find the lowest common multiple, but they think highest common factor is easy. Another way you can find the lowest common multiple, this works for any 2 numbers, is you can multiply them together and you can divide by their highest common factor, because finding the highest common factor is a lot easier. So we can go 40 times 48 divided by 8. Now 40 times 48, that's a big number. So what we can do instead here is we can go 48 divided by 8. Well, that's just 6. So the lowest common multiple is 40 times 6, which gives you 240, okay? So just saying, if you find it a bit difficult to understand that the lowest common multiple is all of these numbers multiplied together, another way you can find the lowest common multiple of 2 numbers is to multiply them together and divide by their highest common factor, because the highest common factor is usually a lot easier to find. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.